So let's face it, dinosaurs are pretty exciting, and so is artificial intelligence. When I was a kid, my science fair project was about dinosaurs and data science, and it led me to all sorts of places around the world. Since that time, I've been one of the leaders of the Mass State Science and Engineering Fair, which has been around now for over 70 years and has been held continuously at MIT. I've also had the chance to do more work in the field of paleontology, attending expeditions and digging up some dinosaurs of my very own, which was always a childhood dream of mine. Here's a 3D printed model of the fossil you're looking at right now. I've also had the chance to work in the field of computers and share that cross-disciplinary knowledge at museums and schools, conferences, and makerspaces around the country. Through that, I've done a lot of work at the Brockton Makerspace. And in addition to being able to 3D print cool velociraptor skulls like this one with students, I've also had the chance to work with students on their own projects and help them get closer to some of their own dreams. For those of you in a position to do so, I strongly encourage you to do that too. This is a brief story about an amazing AI project I've been able to work on with a student in Brockton that I mentor named Christian.
Hello, my name is Christian Nichols and I'm a current junior at Brockton High School. Today, I'll be discussing a project that I have been working on that involves utilizing artificial intelligence and machine learning software to identify invertebrate fossils in expedition sites.
Most expedition sites look like this. This is actually the one I used to visit out in Arizona. At least for vertebrate paleontology, this is about what we can handle in one day. But as you can see in the satellite image, a site like this is only a tiny area compared to all the area you can explore. Well, imagine if you could use high-resolution satellite technology and combine that with high-res photos from drones that are capable of getting very close to the ground. And then you apply artificial intelligence object detection to that. And, well, you can get a really great way of finding fossils more efficiently that way. Due to the pandemic, we couldn't really go out and do field tests, but it was possible to create 3D simulations of drone flyovers. Here you can see a few different simulated fossil locality scenes, with realistic-looking fossils embedded in the matrix, some fully visible and some partially obscured. And it's quite accurate, both with a straight flyover and a flyover that moves from location to location. You could see all the fossils here are being picked up by the system. And that's in part due to recent increases in the accuracies of models and improvements in AI platforms like TensorFlow and Keras, but it's also due to improvements in localization and object identification versus regular classification. And of course, using 3D programs to do lots of data augmentation. It's a great excuse to learn more about 3D programs like Blender. And using tools like photogrammetry, you can make easy 3D models of structures that are complicated, like vertebrate bones and bone textures, meaning one day the system might be able to be used to find dinosaurs.
Hello, my name is Christian Nichols and today I'll be demonstrating how accurate and responsive my model is using fossil casts of ammonites and trilobites. So this first one right here is an ammonite, and you can see with it moving, it still is able to recognize it. This next one right here is also an ammonite. This next one is a trilobite. This next one is also a trilobite. This next one is an ammonite in matrix. And you can see even with extreme movement, it still is able to accurately recognize it. And you can see even with holding up two ammonites, it still is able to recognize them both. You can see with 2 trilobites, it still is able to do the same exact thing, even with extreme movement. And you can see with an ammonite and a trilobite, and the ammonite in matrix and another trilobite. And you can just see with just even more runs that it is able to recognize them with high accuracy.
In the end, Christian's system went from 30% accuracy to over 50% to over 85% in classification using Keras. And for object detection, Christian used TensorFlow's ODAPI, which after running tens of thousands of iterations, and finally hundreds of thousands of iterations with an NVIDIA GPU, the system was able to achieve well over 90% accuracy. And it's incredibly exciting, and it means that this system could really work in the field.
Unfortunately, although I am a dinosaur enthusiast, there aren't enough vertebrate dinosaurs locally that I know of to do something like this that would be effective. So I decided to instead use invertebrate fossils. Invertebrates dominated the planet millions of years ago and can say a lot about our planet's past and geological record. One might think that, why is it important to study fossils? Or why is it important to study Earth's history? My answer for that is, studying the past is essential as we advance forward in society, especially in the context of things that threaten our planet and the future of our civilization, such as climate change, pollution, diseases, and much more. For example, to know why certain diseases are more prevalent now than before, it's important to look in the past for answers. By using artificial intelligence for the first time to help paleontologists discover fossils and expedition sites faster and more accurately, it will be a huge step forward in studying important concepts such as evolutionary patterns. This technology can even be used pathologically by allowing paleontologists to discover diseased fossils and allowing scientists to study them. I first used a generalized model using convolutional neural networks. So far, I've been able to increase my accuracy for these models from 30% to 50% to all the way to 85%. I did this by simply refining the dataset and running more iterations. This points to the idea that I can increase the accuracy even further by feeding the model with even more data and even using data augmentation or 3D models to improve the dataset. Currently, I'm working on using convolutional neural networks for object detection. My plan is to hopefully be able to go out on a paleontological expedition to test my model firsthand and see how accurately it identifies and detects fossils on the field. If not, I would love to be able to do this in a simulated environment with molded fossils such as plaster trilobites, ammonites, and even brachiopods to test out my model. I think this is a groundbreaking method for a new modernized era of paleontology, especially seeing as after the COVID-19 pandemic, expeditions will start to be back on the rise. I'm very excited that there is a bill in state legislation to name a Massachusetts state dinosaur because my research may help to locate more vertebrate dinosaurs such as the Podokesaurus holyokensis. Thank you for listening.
This project was outstanding, not only from the perspective that it's very modern and solves a real-world problem, and it's very cross-disciplinary, but not to mention the performance of the system itself, but we were able to achieve so much together as a mentor and student team in the midst of a pandemic. So I hope the work of Christian inspires you to want to go out and mentor some students of your own, or do a science fair project just like this yourself. If you'd like to mentor student science fair projects, here are a few organizations we recommend. To learn more about AI and how you can use it in projects, please visit us at tumblehomebooks.org. Thanks for watching.